Hello everyone. So from this video we're going to continue where we left. So from here we are going to start from the bag of words. So basically bag of words is like, now we will use the bag of words model, which is a BW model, BOW, which is used to represent text in form of bag of words. That is, the grammar and the order of words in a sentence are not given any importance. Instead, multiplicity, that's the number of times a word occurs in a document, is the main point of concern. So basically, it describes the total occurrences of words within a document. Scikit-learn provides a neat way of performing the bag of words technique using the count vectorizer. So now we will convert the text data into vectors by fitting and transforming the corpus that we have created. So for that, we have to just type CV equals to count vectorizer. We have ngrams underscore range. I'm going to specify 1,2. Train data will be basically CV dot fit underscore transform, and we are going to pass corpus, and X will be our train data and Y will be our df.lead. I'm going to run this piece of code and it has run. Now we will take the ngram range as 1, 2, which signifies bigram, as you know. So ngram is basically a sequence of n words in a row or sentence. Ngram range is a parameter which we use to give importance to the combination of words, such as social media has a different meaning than the word social and media separately. So we can experiment with the value, the ngram underscore range parameters, and select the option which gives better result. Now comes the machine learning model creation part. And in this project, I'm going to use random forest classifier, and we will tune the hyperparameters using the grid search CV. So grid search CV will take the following parameters. It will take estimator or model, which is a random forest classifier in our case. Parameters, which is basically the dictionary of hyperparameter names and their values. CV signifies cross-validation force. Return underscore train underscore returns the training scores of the various models. And n jobs is basically the number of jobs to run parallelly. Default -1 signifies that all CPU cores will be used, which reduces the training time drastically. And now, so for now, first we will create a dictionary parameters which will contain the values different hyperparameters, and we will pass this as a parameter to grid search CV to train our forest classifier model using all possible combination of these parameters to find the best model. So for that, we will use parameters equals to curly braces max features underscore features, and we need to specify auto again, comma sqrt. Now we have to separate it, comma. Now next feature we will do n underscore estimators features. We will use 500, comma 1000, comma 1500, comma we'll use max underscore depth. It will be inside 5, 10, 15, and next will be min samples underscore split, and this will contain the values around. Achha, it actually I gave wrong values now. Just wait. I just made one mistake. I'll just check. 15. In this, the 15 instead of 15, what I want to pass none. None. After this, when samples I'm going to take leaf 1, 2, 5, 10. And finally, I'm going to take the bootstrap. Bootstrap to use the value as true, comma, false. So now when I run this piece of code, parameters are defined. Now we will fit the data into the grid search and view the best parameters using the best params attribute of the grid search. See. So again, for that I have to use grid underscore search equals to grid search CV random forest classifier, and I want to have the best parameters, so I will check it by using the parameters CV equals 5. Then we'll, inside the bracket only return underscore train underscore score. We wanted this value to be true, and we have finally the number of jobs we want to run because we want the maximum usage of our CPU, so we specify -1. And now we just do grid underscore search. We got the fit function on our X and Y, basically the test and train data sets. Search dot best underscore params, which will give us the most ideal parameters for this one particular function. Now I just run this function. Now let's see. Let's just wait, it's taking time. Even after running my entire CPU course, perhaps my laptop is a bit slow. So it is basically taking the entire data set that we have split, and among these parameters, it is choosing the most ideal parameters. And in the output, you will be seeing the what is the most crucial and the important parameters among these set of options it chose, and whichever gave us the most highest output. That is the most accurate one with the optimal. That is perhaps, or we can say simply in terms, the optimal model, optimal parameters. So grid search CV helps us in finding that. Still it is finding. You can even see the functions which are running below. So these are the functions and the time it is taking. And this function is calling this function. It is calling evaluate. Just calling this function. Grab function. Okay. So let me just pause the video and I'll come back when the entire process is done. So when I run this piece of code, I get this particular as the output. So it gives me the best parameters. So bootstrap should be set to true, max step none, max features to auto, min samples to 1, min sample split should be 5, and n estimate should be 500. Now if we can view all the models and their respective parameters, mean test score and rank as grid CV stores all the results in the CV attribute, you can just simply go to the piece of code and you can just write like for in range, let's say 6, and for that we can just print on the respective parameters and we can just pass on their value like grid underscore search.cv underscore results, and again underscore, then I have to take a square bracket, and I can type perhaps square bracket I, and the new line can just add again, copy this value, and if I want to print the mean score error, so I'll type mean test score, and again the value I have, in order to find out the value, I can just type create search.cv underscore results underscore let's say their mean test score now. So in order to do the mean score, we have to just type mean test score, and again the value for the ith value are typing. And finally, if you want to get the rank, so you, for the rank, always you follow the same process, print rank, and you put comma, then font create underscore search.cv results underscore bracket rank underscore test underscore score in square bracket and 9. Now you just need to run this piece of code. So now when you run this piece of code, this is the output you will get. So you can see the bootstrap for the rank 6th, you got this particular for rank 7th, rank 5th, rank 8th, and you even have rank 1 and 3 and so on. You can just find out the values for respective one, like in order to display the models and the respective parameters, mean, to scale, and rank. This is how you can do it. Now moving on. Now we will choose the best parameters that is obtained from the grid search CV and create a final random forest classifier model and then train our model. So for that, we have to do RFC, initializing the random automatically. Max features equals to grid underscore search dot best underscore params, and in square brackets you can pass on the value max underscore features. If that was to pass it again with the comma, we pass the max underscore depth equals to grid underscore search dot again best params underscore max underscore depth. And similarly you can do it by putting on by putting all the respective variables, like substituting all the respective variables. Another thing you can do is like directly put on the values, like directly, instead of using the max features equal to this, taking all the entire these things, you can just directly take that in that we already found out, like the max value, max the best feature. So what you can directly do, in our case the max features were sorted to, I guess, auto, yeah, in comma you have max underscore depth, which you was around max underscore depth was none, so you can set it to none, NONE. And the next features was nestimators equals to our value for an estimators was 500, so you can just type 500 500. And for next features for min samples, so min underscore samples underscore split the value that you gave. For min underscore samples dot get we gave 5, so we can specify 5, comma min underscore samples underscore leaf, we can give value as 1, and finally bootstrap equals to double equals. Bootstrap was true, set to capital true. Yeah. Now you can run this piece of code. Now it has run. Now next step. After we have run this code, our next step is to fit it. So we just put rfc.fit and we pass on our x comma y. Now after we have passed our values, the respective top best optimal parameters. Now we just pass rfc.fit and pass our datasets. Now it has started the training of the model with the optimal parameters, that is the hyperparameters. Now it will take some time. Until then I can just pause the video. Now after it has trained, I'll come back. Now you can see it has stopped, that is the training has been completed. So this is the particular output. Now the next task is basically we will be test our data transformation. Now we will read the test data, that is the data that was in our test.csv, test.txt file, and perform the same transformation we did on the training data, and we will evaluate the model on its prediction. So again, for the test.data, first of all I have to import it. So for importing, I'll do pd.read underscore csv, pass the tst.txt test, then delimiter was semicolon, I guess. Yeah. And then I have to transfer names equals to, as we know, that were again text followed by label. Now this is how we're going to test. I'm going to run this piece of code and our test date has been implemented. Now the next task is to just prepare the data set. So what I'll do is text underscore test comma y underscore test should be this underscore df dot text comma test underscore tf dot label. Now I have to encode it, so we can just type encode the, let me just write comments, labels into two classes 0 and 1. I'll use test underscore tf equals to custom. See, it has appeared in the first line itself, suggested one underscore test. Now I have to pre-process, so I'll again use pre-processing of text. In order to pre-process, I'll just use test underscore corpus equals to text underscore transformation, and inside the brackets I'll use x underscore test. Now finally what I'll do, I'll convert text data into vectors, and for that I use just test data equals to cv dot transform, and we'll pass test corpus. Now finally, we will predict the target. For that, we just have to do predictions equals to rfc dot predict, and we'll pass the test data. Now I'll run this piece of code. Okay, says okay, that means it's already been trained. Sorry. Now the final task is to just evaluate, that is the model evaluation. So we will evaluate our model using various metrics such as accuracy score, precision score, recall score, confusion metrics, and we will even create a ROC curve to visualize how our model performs. So that again, we have to use RC params, and we have to specify the figure dot fig size 10,5. Then we choose plot underscore confusion matrix, and we'll give phi underscore test comma predictions, and for accuracy we'll give accuracy score equals to accuracy score. For y test data, because we are performing for test data, we will write this, and again pre-score precision scores equals to precision underscore score. Again, for test data we are performing, comma predictions, that will compare the both, and PC score for false score, again same values. Now we'll print the accuracy underscore score, comma accuracy underscore score. Now again print statement for printing the precision score as the p underscore score. Finally, I will print the recall score as well. Recall underscore score c underscore print whatever the value multiplied by 50, CR equals to classification report y underscore test comma predictions, and finally we will print the CR report. Now when I run this piece of code, and you can see the accuracy is basically around 96%, precision is around 96% again, recall is 95.7. So you can see the value, and the report is also being generated, so you can even see the report. And perhaps as you don't know that F1 score is basically the harmonic mean of precision and recall, so you can see the respective values. And there's also a confusion matrix has been generated, so you can see the confusion matrix around here. So this is about the data how it has been presented. Now let's move on to the ROC curve. We will also draw the ROC curve. So we will basically in ROC curve, we will find the probability of the class using the predict proba method of random forest classifier, and then we will plot the ROC curve. So again, we use predictions underscore probability equals to rfc dot predict underscore proba, and we will pass on the test data. And the next slide, we take the two value FPR, TPR for true positive rates, FPR for false positive rates, thresholds values that we will be using, ROC underscore curve function we'll pass on. Again, we want to pass on the test data. We need predictions as well. And I think we need prediction probability. So we won't pass prediction, but instead we'll pass prediction probability. And the square bracket, we're going to pass every value. And we just need the first column. So these are the predictions probability. On the new line, we'll just plot plt dot plot fpr comma tpr plt dot plot. We'll be plotting 0, 1 plt dot title. We want to even give the title to a function. If roc curve, sorry, now plt dot x label, we are going to label the axis as well. False positive rate. Plt dot y label, true positive rate. And finally, for displaying the picture, plt dot show. Now we'll run this code and we got the output. Now, as we can see that our model performed very well in classifying the sentiments with the accuracy, precision score and recall of approx 96%. And the ROC curves and confusion metrics are great as well, as which means that our model is able to classify the labels accurately with fewer chances of error. Now we will check for custom input as well and let our model identify the sentiment of the input statement. So let's create a function for predicting the custom output that we'll give. So we'll just name it as expression check, expression underscore check. Okay, that's a good name. Prediction underscore input if prediction underscore input double equals to 0, we have to print that input statement has negative sentiment, and else if elif, in Python use elif, prediction input double equals to 1, I have to print, just wait, I'll just set up the indentation error afterwards. Input statement has positive sentiment. Finally, we have else. We'll print that if both doesn't belong to these categories, the sentence you are saying is invalid statement. Now let's run the code after clearing indentation. Function must return. Now I'll write a function to take the input statement and perform the same transformation that we did earlier. So for that, first of all, let me just write the take the input statement and perform transformation. We did earlier. Okay. So for that, we'll just define a function def sentiment predictor. The important function in our entire project, we'll pass in the input and we'll just text transformation function that we just created. We'll pass on the input. Oh God, sorry. Input. Now I have transformed input. I want to cv dot transform the input. Prediction will be equals to rfc dot predict. Expression check prediction. I'll run this piece of code. Test run. Finally, we'll test with some input. Let me just take any two inputs. Let me just copy it from other. So I've taken these two inputs. The first input is basically sometimes I just want to punch someone in the face. And input 2 is I bought a new phone and it's so good. Now with the human level, you can understand that the first is basically sadness or anger, denoting to some labeled as 0. And the input 2 is like giving a positive impact. So it is basically giving us the sentiment as 1, label 1. Now I have to just classify it. So I'll just use that function predictor input 1 and sentiment input 2. I'll just run this piece of code and we can see, and voila, you can see input statement has negative sentiment and input statement 2 has positive sentiment, that is just reflecting to the second one. Yeah, so hooray, as we can see our model accurately classified the sentiments behind the two sentences. And this was much about the sentiment analysis and this tutorial, and this is, I hope you enjoyed the video and thank you so much for giving time, and I hope you would have taken a lot from this video. And yeah, see you again. Thank you. Bye.